Most DevOps engineers think if Kubernetes deployment is successful, the system is healthy. Pods are running, service is reachable, CI/CD is green, so everyone relaxes. But today I'll show you a real production DevSecOps problem where everything looked completely normal while security was completely broken. If you want to work on real production systems, this is the kind of thing you need to understand, not just Kubernetes commands, but how production systems silently fail. If you are new to my channel, like this video, comment Kubernetes so that I can send you the full source code. Now, let's build this step by step. I'm going to jump back to my Visual Studio Code. Here, we already did episode 1 and 2. Now I am going to create another folder called episode 3. I will say episode 3 Kubernetes RBAC risk. So this is all about RBAC. I'm going to explain in detail. Stick around till the end. I'm going to keep this setup very simple because real production incidents usually come from small operational mistakes, not huge complicated architectures. First, I'm going to create a Python file app.py. So in this file, we are going to write some code, very simple once again, like we did in our previous episodes. So if you look at this particular code, here I am trying to expose environment variables directly in the response. Never do this in production, but mistakes like this happen more often than people think. Many people just do it for testing purposes and they push all of this to GitHub repository. Followed by, I'm going to create requirements.txt file, and in that I'm going to add Flask. Very simple, as I said. Followed by, we are going to create a Docker file. So again, Docker file we already did in our previous episode. I already explained. If you haven't watched that, please go watch that video as well. So this is again the simple Docker file wherein we are trying to create a user, copy the requirements.txt file, installing all the stuff, and also trying to run the application. Now let's try to build this image real quick. For that, I'm going to use Docker build DevSecOps -kh version 1. Press enter. The image is getting built right now. Followed by, we are going to create a insecure deployment.yaml file. The image is ready now. This looks normal. Everything is fine so far. Now I'm going to create another file called deployment bad.yaml. Okay, so in this file I'm going to add some deployment code. So this is very simple deployment. Once again, insecure app name followed by the container name we are trying to give here. Then image would be DevSecOps K8 colon version 1, which we built just now. Followed by, if you look here carefully, this is the very dangerous part. We are hard coding production secret directly inside deployment YAML file. Okay. Now Kubernetes will happily accept this. deployments will be succeeded, but security is already broken before we even do anything. Followed by, I'm going to create this service real quick. In the same folder, we are going to create this service file. I will say service bat.yaml, and in this file, I'm going to expose it to the node port 3000 30080. Again, I mean, Kubernetes is completely okay with this. Now we are going to load the Docker image into the cluster so that we can deploy the YAML files. First, we are going to start with deployment.yaml file. I'm going to run kubectl apply command here. Followed by, we are going to create the service bat.yaml file. kubectl service got created, deployment got created. Now let's try to run kubectl get pods. Press enter. If you see, pods are running fine, right? Also, let's try to run kubectl get svc. Press enter. This also looks good. Our pods are healthy, service is reachable, deployment succeeded. So, many engineers stop troubleshooting here. But in reality, security is broken. Now, let's try to run kubectl port forward insecure service. Followed by, I'm going to jump back to the other terminal. In this terminal, let's try to run curl http localhost port 8080. Press enter. Now look at this very carefully. Application is running. Environment we can see. Database password as well. It's completely visible in production environment. We just exposed internal secrets publicly. Attackers don't always need complicated exploits. Sometimes applications expose sensitive information directly because of poor deployment practices. Kubernetes in itself is healthy. So, kubectl get pods. This is healthy. CI/CD pipeline is also healthy. Monitoring may still show green, but security is completely broken. Infrastructure health does not equal to security. Now, this is already dangerous. But the real problem is something much worse. I'm going to create another file, name it as RBAC bad.yaml. So, in this file, we are going to add some code once again. So, what exactly we are trying to do here? This is the service account which is supposed to deploy application. Normally in CI/CD pipelines we use service accounts, but someone gave cluster admin permissions. Usually this happens because deployment was failing for some reason. Permissions were annoying. I mean, this actually happens in real production environments, and engineers wanted a quick fix. Okay, as an engineer, you want to fix the issue real quick. You will give cluster admin access just for testing purposes. Now, I'm going to save this. Followed by, let's try to apply this real quick. I'm going to say kubectl apply -f rbac bad.yaml. Press enter. If you see service account created, RBAC authorization created with CI/CD deployer admin. Now I will say kubectl auth, can I get secrets? It says yes. Now, the CI/CD pipeline can read secrets from the entire cluster. Also, followed by, I will say, can I delete deployments? I get a yes again. If CI/CD gets compromised, attackers get these permissions. Now, attacker can read secrets, destroy workloads, modify our deployment files, access namespaces. This becomes a cluster-wide security problem. So, how are we going to fix this? For that, I'm going to create a I'm going to create a new secret.yaml file. In this file, I will give my actual password information. So, for example, if you see here, I'm going to give it a name, secret, and string data, db password. Now I'm going to kubectl apply secret.yaml. Secret got created successfully. Now this is better than hard coding passwords directly in deployment.yaml file. But in real production environments, many companies don't manually create Kubernetes secrets like this. Usually, secrets come from Azure Key Vault, AWS Secret Manager, HashiCorp Vault, because Kubernetes often integrates with external secret systems. So instead of developers manually creating secrets inside the cluster, applications pull them securely from centralized secret management platforms. Because once secrets are manually copied everywhere, they become difficult to rotate, difficult to audit, and also difficult to secure. Followed by, we are going to create a new file, deploymentfix.yaml. So in this file, I'm going to add the exact code once again with reference to the secret. Name, DB password, value from secret key reference, application secret, which we already created here. So instead of hard coding it, I am going to add this in our deployment.yaml file. Now the password is no longer hard coded directly in the YAML file. But this alone is not enough. Kubernetes secrets protects how the value is stored and injected. It does not protect you if your application prints the secret back to the users, right? So I'm going to create another file named rbacfix.yaml real quick. So in this file, we are going to explicitly assign the permissions. So for that, I will say here I'm going to add deployment permission. For example, get, list, watch, create, update, patch. So these are the kind of permissions which we are going to assign, and here the deployment manager role reference we are trying to give. Now let's try to run kubectl RBAC fix.yaml. Press enter. Now if you see CI/CD deployer safe created, deployment manager created, deployment manager binding created. Now once again, if I try to run kubectl auth, can I get secret? Press enter. Now I get it as no. Previously we were getting it as yes. Now the CI/CD service account only has permission it actually needs. It does not have the full cluster access. Once this is done, I'm going to jump back to the application code, and in this code, I'm going to update this real quick. So previously we had this exposed. Now I'm going to say application running securely. Save this real quick. Followed by we are going to build this Docker build DevSecOps K8's version 2. Then we are going to load this image into the cluster. Followed by we are going to set this image into the deployment. Press enter. Image got updated successfully. Finally, we are going to do a rollout. kubectl rollout status deployment in secure app. Press enter. Successfully rolled out. Finally, let's try to run the port forward once again. Now, let's try to access it. Curl localhost colon 8080. Now you see application running securely. Same Kubernetes deployment, but production safe. In episode 1, we spoke about insecure infrastructure. Episode 2, we saw vulnerability containers. Today, we saw how Kubernetes deployments and RBAC mistakes can silently create massive security risk. Next episode, we will look at how production secrets leak through CI/CD debugging. This is why DevSecOps is not just about scanning tools, it's understanding how security failures happen inside normal operational workflows. Most production incidents don't happen because systems are down, they happen because systems are insecure while still looking healthy. Thank you for watching and see you in the next video.